Welcome back. Problem 9-29. This problem is taken from chapter number 9, that is stress transformation, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the 3-inch diameter shaft is supported by smooth bearing, thrust bearing at A and smooth journal bearing at B. Determine the principal stresses and maximum in plane shear stress at a point on the outer surface of the shaft at section AA. So you can see this is the shaft. At point A we have smooth thrust bearing, and at point B we have journal bearing. The loading here is shown. This is axial load, and there are two torques at two different points opposite to each other are shown over here. So you have to determine the maximum principal stresses and in plane shear stress at this section AA on the outer surface of this shaft. So let's start with the solution. So first step is that if you remove this smooth thrust bearing, so you will be having a reaction, vertical reaction force, which is equal to RAY, and as well as there will be a horizontal reaction force which will be equal to RAX. And similarly, if you remove this journal bearing, smooth journal bearing, so you will be having only vertical reaction force, that is RB. We will find this unknown reaction force by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So here we can see that this is your x-axis. On vertical you have y-axis, and in this direction you have z-axis. Clear? So remove this. Remember this sum of all forces along y direction must be equal to 0. So RAY, which is upward, plus RB is equal to 0. So this is your equation number 1. Now we'll apply another equation of equilibrium, that sum of all forces along horizontal direction must be equal to 0 and force in this direction is taken as positive. So horizontally we have 3 kips and RAX. So RAX minus RAX, because that is opposite to this x, plus 3 kips is equal to 0. So it means that RAX is equal to 3 kips. Now we will find this RB by using equation of equilibrium, that sum of all moments about point A is equal to 0, taking the counterclockwise moment as positive. So about this point A, one moment will be RB into perpendicular distance. The total distance is this one, which is not given. Let this distance is equal to L. So I will write it RB into length L, and this is producing counterclockwise rotation, so it will be positive. Clear? So and we have torques about this point. This is point A, our x-axis. So one is 500 counterclockwise, another one is clockwise. So minus 500 plus 500 will be equal to 0. So it means that RB into length is equal to 0. So from here length cannot be 0. So it means that RB is equal to 0. Now you have RB is equal to 0. So put RB in equation number 1. So you will get RAY is also equal to 0. Now you have these forces. It means that these bearings are not offering any vertical reaction. So what we will do is that now you will cut this shaft at section AA, here at section AA, and you will draw the free body diagram. So let me draw it. Let this is the shaft. Clear? At this end we have 3 kips load. Clear? That is 3 kip. This is your point B. Clear? And there is a torque of 500 in clockwise, 500 pounds into feet, and this is your section AA. At this point we have x-axis in this direction, clear. Similarly y in vertical direction and z is in this direction. This is your axis. So when you cut it, so you will be having a normal force that will be acting opposite to this will be normal force. Let this force is n, and you will be having a torque opposite to this that will be counterclockwise, and this torque will be represented as T. So we'll find this torque and N by using equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force in positive x direction is taken as positive. So you can see this is opposite to this x, so it will be minus N, and this plus 3 is equal to 0. So it means that N is equal to 3k. Now we'll find this torque. So you can see that this is counterclockwise torque and this is clockwise torque. So their sum of all this torque must be equal to 0. So T will be equal, T minus 500 is equal to 0. So it means that this torque is equal to 500 pounds into feet. That will be in counterclockwise direction, this reaction torque. Now we will have due to this normal force, you can see this normal force, we will be having normal stress, and due to this torque we will be having a shear force acting on it. So first we will find the normal stress. So normal stress will be equal to force per unit area. So N is given as 3 kPa. So 3 that is compressive load. You can see that this is compressive, this and this is compressive, causing the shaft to compress. So it will be minus, I will write minus, no, minus 3 kPa. So 10 raised to power 3. It will be converted into pounds. And what about area? So this is circular shaft having diameter 3 inch. So it will be, area will be equal to pi by 4 d square, pi by 4 d square, and d square is 3. Clear? That will give us minus 3000 divided by area will be 2.25 pi. This will be pound and this will be inch square. So that this stress will give you minus 4 to 4.41 pound per square inch. So that will be equal to psi. Now we'll find the shear stress due to torque. Shear stress due to torque T. We know that shear stress due to torque T is equal to T into C divided by J, where T is torque, C is the radius, and J is polar moment of inertia. So J for circular rod having, if D is equal to 3 inch, so radius will be equal to 3 divided by 2 is equal to 1.5 inch. So J for rod having radius R is given as pi by 2 r power 4. Clear? So pi divided by 2 into r is 1.5 power 4. So when you calculate it, you will get 2.53125 inch power 4. And C is distance, C is radius, distance from neutral axis till the topmost. So that is radius, and that is 1.5 inch. So now you just put the value, so you will get the shear stress is equal to torque, which is equal to 500 pounds into feet. So we will convert it into inch. So feet, 1 feet is 12 inch. So this will be, torque will be equal to pound into inch, and C will be 1.5 divided by J. This will be inch divided by J is 2.53125 pi. Clear? There is a pi as well over here. Okay, and this unit will be inch power 4. So when you calculate it, you will get the shear stress comes out to be 1131.77 psi. So if you draw the state of stress on the element like this, so you can see that you have stress in x direction is minus 4 to 1, 4 to 4, that is compressive. So your sigma x will be equal to minus 4 to 4.41 psi. There is no stress in y direction, and we have shear stress tau of xy. So this is y direction, this is tau of xy. That will be like this. This is tau of xy. Tau of xy, that is 1131.77 psi. Now we are going to find out principal stresses. So we have sigma x is minus 4 to 4.41 psi. You have sigma y is equal to 0 and tau of xy is 1131.77 psi. So first we will find principal stresses. So principal stress is equal to sigma 1 comma sigma 2 is equal to sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy square. So put the value minus 4 to 4.41 plus 0 divided by 2 plus minus 4 to 4.41 minus 0 divided by 2 whole square plus 1131.77 square, and this will give you sigma 1 comma 2. So when you solve it for plus, take this value plus this will give you sigma 1, and when you solve this due to limitation of space, you can solve it. Sigma 1 is 939.28 psi, and when you take this term minus this term, so you will get sigma 2, and this sigma 2 comes out to be minus 1363.70 psi. So these are the principal stresses. Now we'll find the maximum in plane shear stress. So that is maximum in plane, and for that we have formula that is equal to sigma x minus sigma y divided by 2 whole square plus tau of xy square. So minus 4 to 4.41 minus 0 divided by 2 whole square plus 1131.77 square under the root will be equal to the in plane maximum shear stress, and that comes out to be 1151.49 psi. Or you can say that maximum in plane shear stress in term of KSI will be equal to 1.15 KSI. So this is the value of maximum in plane shear stress, and these are the principal stresses that occur on the outer surface of this short head section AA. And that was all about this problem 9-29. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share it with your communities so that they may also learn and help me in growing my channel further.